video, we're talking about population standard deviation. This is the big one. This is the one that you will use most often, and it's incredibly easy to figure out. So we have a couple different things. We'll talk about the formula, the properties of the standard deviation, and how we interpret it. So it is the most commonly reported measure of dispersion. If you read any research articles, you will see standard deviation. And standard deviation is just very simply the square root of the variance. Once you know the variance, standard deviation is a snap. So let's take a look at this formula for standard deviation. You'll notice that sigma no longer has the squared symbol because we are taking the square root of sigma, basically the square root of variance, to find standard deviation. So we had the sums of squares over n was the formula for variance. Take the square root of that and you now have standard deviation. Standard deviation is essentially a transformation. It returns what we were working with variance to its original units of measurement. Because remember, we squared those units and now we're turning them back into being unsquared, so to speak. It helps us to make more meaningful comparative statements. So here's an example. For group A, we had the variance of 6.67. Let's say that this was a quiz and these were points that we were talking about. We would interpret variance to mean that the scores varied on average 6.67 squared points. It's kind of hard to understand. But when we take the square root of the variance and we return it back to the original units of plain old points, then we would say the scores varied on average from the mean 2.58 points. So we're taking those squared units and turning them back into their original units. So group B, the variance was 4. So if we take the square root of 4, we end up with a standard deviation of 2. So instead of saying that the scores varied on average 4 squared points, we can say the score varied on average from the mean 2 points. It makes it just much more understandable. So again, here is a picture of what this looks like. So group A varied on average 2.58 units or points from the mean, and group B varied on average 2 points from the mean. So what we're going to talk about now is how we would interpret standard deviation in a graph such as this. So as you look at this graph, we have a distribution of scores, and the mean is 36. You can see that right in the middle, and the standard deviation is 4. Which means on average, the scores in this distribution vary from the mean by 4 points. So you'll notice that most of the scores are within 4 points or are within 1 standard deviation. Most of the scores are between 32 and 40 points. That's plus or minus what we call 1 standard deviation. The standard deviation being 4. 36 plus 4 is 40. 36 minus 4 is 32. Most of the scores are within 1 standard deviation above or below the mean. Yeah, we have some scores that are further away, but most of them cluster towards the center. So what I'm going to do is I'm going to have us calculate the population variance and standard deviation for the following scores. So I'm going to show you how to set this up on your paper. All right, take a moment and make sure that you have your paper set up just like this. You have all of the scores listed. You have a deviation column. You have the squared deviation column. And you have these instructions here written down. And we will get started. So the very first thing we need to do is sum up all the scores. Why do I need to do that? Because I need to find the mean. So here we go. 10 plus 5 is 15, 18, 27, 32, 33, 41, 42, 45. Okay, that was fast. 45. Now I need to know the number of scores in order to calculate the mean. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 scores. 9 goes into 45 5 times. So I know that my mean is 5. This is what I'm going to be subtracting from every single score. Let's do that. 10 minus 5 is 5. 5 minus 5 is 0. 3 minus 5 is negative 2. 9 minus 5 is 4. 5 minus 5 is 0. 1 minus 5 is a negative 4. 8 minus 5 is 3. 1 minus 5 is -4, and 3 minus 5 is a -2. Now, how do I kind of make sure that I've done my deviations correctly? Well, from the last time, I mentioned that if you add up all your deviations, they'll equal 0. So let's check that. 5 plus 0 is 5, minus 2 is 3, plus 4 is 7, minus 4 is 3, plus 3 is 6, minus 4 is 2, minus 2 is 0. So these do all total to 0. That tells me that I've done my deviations right, and this is why we can't just average this column. We have to square them first, and then we'll take the square root. So let's take this, let's square all of these deviation scores, and we have 25 plus 0 plus 4. 4 times 4 is 16, 0, 16, 9, 16, and 4. So I've just squared all of these numbers. And now I need to sum them all up. SS means sum of squared deviations, or sum of squares. 25, 29, 39, 45, 55, 61, 70, 86, 90. So my sums of squares is 90. That's the total. And I know that to find variance, I take my sums of squares of 90 and I divide it by the n of 9. My n is 9. So my variance is 10. So the very last step is to find the square root of 10. And the square root of 10 is equal to 3.16. So my standard deviation is 3.16. So what I can say is these scores on average vary from the mean by 3.16 points. There you go. So let's talk about a couple different ways of playing with standard deviation. If a constant is added, which means the same number is added to every score in the distribution, the standard deviation doesn't change. Because what you're just essentially doing is you're adding to the same score to every score in the distribution. You're just moving the distribution over. You're moving the center of the distribution over. But the distance between the scores doesn't change. So think of the scores if they're in a histogram and you add 2 points to each score, you're really just shifting the whole distribution to a new location, but the relationship between the scores has not changed. So the center of the distribution, the mean changes, but the standard deviation stays the same. But if we multiply a constant to every score, the distance between the scores will change, and because it does so, the standard deviation will also be multiplied by that same number. So if you visualize a histogram and you multiply each score by 2, for example, the distance between those scores will increase. And so in this case, we're not just picking up and moving a distribution, but we're actually increasing the distance between points in the distribution. So let's try some things. A population of n equals 80 has a mean of 25 and a standard deviation of 4. What is the population variance? So we have practice going from population variance to standard deviation. So what do we do if we know the standard deviation, but we want to know the variance? Well, we're just going to square the standard deviation. So if we take the square root of the population variance to find the standard deviation, you can turn it back into the variance by squaring it. So think of it that way. The variance is the standard deviation squared. Here's a hint to that. Standard deviation doesn't have any exponent here, but variance does. So this shows you that variance is standard deviation squared. All right, did that blow your mind? If a population has a mean of 70 and a standard deviation of 5, and we add 10 points to every score in the population, what are the new values for the mean and the standard deviation? You're going to have to think back to the rules about what we do when we add a constant and how it affects the mean. But think about that for a minute. All right, here it is. The mean would be 80. It would change, but the standard deviation would stay the same, just because of those rules we just talked about. So when we add a constant to scores, the mean is affected. The mean is also added by that same amount. But the standard deviation doesn't change when we're adding the same number to every single score. Here's one more. A population has a mean of 70 and a standard deviation of 5. If every score in the population were multiplied by 2, what would be the new values for the mean and standard deviation? Ponder on that for just a moment. Okay, well, what we would do when we're multiplying, the mean is also multiplied. That's again review from the last lesson. So 70 multiplied by 2 would be 140. And again, from the rule that we just talked about, when we multiply this same number by every number in the distribution, we'd have to do that to the standard deviation as well. So 2 times 5 is 10. All right, some mental gymnastics with the standard deviation. I will see you at the next video.